Hello and welcome to this engaging session on security vulnerabilities, a cornerstone topic in the field of information security. A comprehensive understanding of vulnerabilities is essential for every cybersecurity professional, as these weaknesses are often the very points that attackers exploit to compromise systems, steal sensitive data, or disrupt critical services. Whether your role involves designing secure systems, managing information technology operations, or responding to security incidents, mastering the identification and management of vulnerabilities is indispensable in today's rapidly evolving threat landscape. To begin, let us define what a vulnerability is in the context of cybersecurity. A vulnerability is any flaw, gap, or weakness in a system that could be leveraged by a threat actor to gain unauthorized access or inflict harm. To put this into perspective, consider the analogy of a house with an unlocked door or an open window. Regardless of how advanced the alarm system may be, if there is an accessible entry point, the security of the house is compromised. Vulnerabilities can take many forms, such as outdated software, weak authentication mechanisms, misconfigured network devices, or insufficiently trained employees. The importance of understanding vulnerabilities cannot be overstated. Cybercriminals, ranging from individual hackers to organized crime groups and nation-state actors, are constantly searching for these weak points. Their objective is to exploit vulnerabilities to gain control over systems, exfiltrate confidential data, or disrupt business operations. For example, an unpatched web server may contain a flaw that allows a remote attacker to execute commands, install malicious software, or move laterally within the network. The consequences of such exploitation can vary from minor service interruptions to catastrophic breaches with significant financial, reputational, and legal impacts. Vulnerabilities aren't confined to technical flaws in software or hardware. They can be broadly categorized into technical and non-technical vulnerabilities. Technical vulnerabilities are those embedded in the code, design, or configuration of systems, applications, or infrastructure. Examples of technical vulnerabilities include buffer overflows, unpatched operating systems, insecure communication protocols, or misconfigured firewalls. Non-technical vulnerabilities, by contrast, are rooted in human factors. Social engineering is a prime example, where attackers exploit the lack of security awareness among employees. An attacker might craft a convincing email that persuades an employee to disclose login credentials or click on a malicious link, thereby circumventing technical controls through psychological manipulation. Research consistently shows that human error is a leading cause of security incidents, highlighting the necessity for ongoing training and awareness initiatives within organizations. Effective vulnerability management begins with identification and assessment. Organizations must systematically scan their systems, networks, and applications to uncover potential weaknesses. Specialized tools, known as vulnerability scanners, automate this process by checking for missing patches, insecure configurations, or outdated software versions. These tools support a proactive security posture, enabling teams to detect and address vulnerabilities before they can be exploited by attackers. For instance, enterprise environments routinely scan their Windows and Linux systems, network devices, or web applications to ensure that all components are current and compliant with security standards. After vulnerabilities are identified, prioritization based on risk becomes essential. Not all vulnerabilities present the same level of threat, and addressing every issue immediately is often impractical, especially in large organizations with complex information technology infrastructures. This is where frameworks such as the Common Vulnerability Scoring System, or CVSS, become invaluable. CVSS provides a standardized method for assessing the severity of vulnerabilities by considering factors such as the ease of exploitation, potential impact, or the level of access required. A vulnerability with a high CVSS score is considered critical and should be remediated as a top priority, while those with lower scores can be scheduled for later attention. This risk-based approach ensures that limited resources are allocated efficiently, focusing on vulnerabilities that could have the most severe consequences if left unaddressed. The industry also relies on standardized identifiers to track vulnerabilities. The Common Vulnerabilities and Exposures, or CVE system, assigns unique identifiers to publicly known vulnerabilities. These CVE numbers are referenced in vendor security bulletins, threat intelligence feeds, or vulnerability databases, allowing security professionals to stay informed about relevant risks in the products and platforms they manage. Major software vendors such as Microsoft, Cisco, Oracle, or various Linux distributions regularly publish bulletins that highlight newly discovered vulnerabilities, their CVE numbers, or recommended remediation steps. To illustrate the importance of timely vulnerability management, consider the widespread WannaCry or NotPetya ransomware outbreaks that occurred in the year 2017. Both attacks exploited a vulnerability in Microsoft Windows for which a security patch had already been released. Unfortunately, many organizations had not applied the patch in time, leaving their systems exposed. The result was a global wave of ransomware infections that crippled hospitals, shipping companies, or government agencies, causing billions of dollars in damages and widespread operational chaos. This example demonstrates that merely knowing about vulnerabilities is insufficient, as timely action is critical to prevent real-world harm. However, not all vulnerabilities are known in advance. The concept of zero-day vulnerabilities refers to flaws that are unknown to the vendor or have not yet been patched. When attackers discover and exploit such vulnerabilities before a fix is available, the result is known as a zero-day attack. These incidents are particularly dangerous because traditional defenses may not recognize the threat, leaving organizations exposed until a patch or mitigation is developed. Defending against zero-day vulnerabilities requires advanced security measures, such as behavioral analytics, intrusion detection systems, or endpoint protection solutions that can identify unusual activity even when there is no known signature. Addressing vulnerabilities is not always as straightforward as immediately applying a patch. In complex enterprise environments, deploying untested patches can lead to operational disruptions, compatibility issues, or unexpected downtime. To minimize these risks, organizations implement structured patch management processes. This typically involves testing patches in a controlled or non-production environment to ensure compatibility and stability before deploying them to live systems. Such diligence balances the urgency of closing security gaps with the need to maintain uninterrupted business operations. Ongoing vulnerability management extends beyond technical solutions to include organizational processes or policies. Security managers play a pivotal role in overseeing the entire vulnerability lifecycle. Their responsibilities include ensuring regular vulnerability assessments, coordinating with information technology and business units to schedule remediation efforts, or monitoring compliance with industry standards and regulatory requirements. For example, standards such as the Payment Card Industry Data Security Standard, or PCI DSS, mandate that high or critical vulnerabilities must be addressed within 1 month of disclosure to maintain compliance. Failure to meet these requirements can result in penalties, loss of certifications, or increased risk exposure. Staying informed about the evolving threat landscape is also essential for effective vulnerability management. Security professionals should actively engage with the broader cybersecurity community by subscribing to threat intelligence feeds, participating in industry forums, or attending conferences or webinars. Collaboration and information sharing help organizations anticipate emerging risks and adopt best practices for defense. Additionally, fostering a security-aware culture among employees through regular training or simulated phishing exercises reduces the likelihood of successful social engineering attacks, thereby strengthening the organization's overall security posture. The professional relevance of robust vulnerability management spans all sectors. In healthcare, protecting patient data from breaches is both a regulatory and ethical imperative. A single unpatched system could expose thousands of sensitive records, jeopardizing patient privacy or organizational reputation. In the financial industry, where systems process trillions of dollars in transactions, vulnerabilities can be exploited for fraud or to disrupt critical services. Even small businesses are not immune, as attackers often target less mature environments with automated tools designed to exploit known weaknesses. Organizations that excel in vulnerability management demonstrate greater resilience in the face of cyber threats. They reduce their attack surface, respond more effectively to incidents, or maintain the trust of their customers and partners. Conversely, organizations that neglect vulnerability management are at greater risk of data breaches, financial loss, regulatory sanctions, or reputational damage. The stakes are high, and the responsibility to safeguard digital assets falls on everyone involved in building, managing, or using technology. To conclude our discussion, vulnerabilities are an inherent aspect of any information system, but their potential for harm depends entirely on how they are identified, prioritized, or remediated. Effective vulnerability management requires a proactive, structured approach that combines technical solutions, organizational processes, or continuous education. By staying informed, adhering to best practices, and fostering a culture of security awareness, organizations and professionals can significantly reduce their exposure to attacks and enhance their overall cyber resilience. This concludes our session on security vulnerabilities.